Okay, so we've been doing things with regard to graphical characteristics, and this is the first page that we've been on in section 3.2 where there's actually not a graph. We are going to be going to our graphing utilities here shortly. All right. However, what I'd like to do is I want to spend some time reviewing some algebra. All right, because remember, just because we now are using graphs and we want to go to our technology, there's actually algebra behind everything we do. So what I have here, so we will go to the graphing technology in a bit, but what I have here is a function, right? The function is x plus 1 over x minus 2 minus 3. And so it's a rational function because of that, and that minus 3, we could put it together. But what I'd like to do first, before we go and use a picture, right, can we do some of these without a picture? And the ones that we can, we will, and the ones that we can't, we'll wait for the picture. And then what I'm hoping happens as well is all our answers that we do algebraically, we're actually going to see on the picture itself. So again, the graph will be a tool to support our algebra. All right, so bear with me there. So for this function, are we able to find the domain? All right, can we do that without a graphing utility or graph? And of course, the answer to this is yes. All right, what we're basically looking for, if you recall from a couple sections ago, we're looking for red flags, right? We're looking for square roots. Well, that doesn't have any, right? And we're looking for any potential divisions by divisions by 0, and we definitely have a potential division by 0 here. So we have to rule out, right? We don't want x minus 2 to be 0. Adding 2 to both sides, we effectively don't want x to be equal to negative 2. All right, so we're talking about all x equal to, or not equal to 2, or an interval notation. We're talking about this. I think I've alluded to some other issues, but with some other graphs that we've seen, but we're expecting is a vertical asymptote there. And when we go to the graph, I will point that out to you guys. Alrighty, so there's what we can actually find the domain without a picture. We look for our red flags. It's something we've done before. What about the range? Right, so if you go back and think, have we ever done range without a picture? And the answer is no. All right, so a general rule is to find the range, we need to have a picture. There are some functions, as we'll find, that we can do it without one, but generally the answer is no. All right, so we definitely need a picture to answer B. So let me go ahead and highlight B. That one will need the picture to help us out. Can I show that the 0.31 is on the graph of g of x? Is that something we can do without the graphing calculator? And I hope you guys are saying yes, right? All I'm basically saying is x is 3, and I want to know is y 1. So I just go to the function g of 3. If I plug things in, I get 3 plus 1 over 3 minus 2 minus 3. That's going to give us 4 over 1 minus 3. And 4 minus 1, or 4 minus 3, we get 1. So the answer is yes. When the input's 3, the output's 1. All right, so this is basically a true statement. All right, and we'll be able to see that on a graphing utility here shortly when we get there, right? Because we will turn to technology. So that one can be done. Can I find the y-intercepts without a graphing calculator? And again, the answer to this is yes, right? To find the y-intercept, what we did in the past is we basically let x equal to 0. So we're essentially finding g of 0. So plugging 0 in here, I think we get negative 1/2 minus 3, and it looks like we get negative 3.5. So the y-intercept is 0, negative 3.5. So when we do turn to the graphing technology, we'll be able to verify that that's actually a true statement, that we actually have negative 3/2 for our graphing calculator. All right. Can we find the x-intercept without a graphing calculator? And again, the answer to this is yes. Right. What we did in the past is we usually let y equal to 0. That means g of x is 0. So we basically have to solve the equation x plus 1 over x minus 2 is equal to 3. And so how do we solve equations like that? Well, perhaps we add 3 to both sides, right? We clear the denominator by multiplying both sides by it. Oops, now it doesn't clear over there. We get x plus 1 equals 3x minus 6, I believe. And if we just keep going, negative 3x minus 1, we get negative 2x equals, is that negative 7? Divide both sides by negative 2, oops, and we get x equals 7/2, all right, or basically 5.5. So our x-intercept is at 5.5, 0. So when I do turn to the technology, we're going to be able to see if that's a true statement or not. So far, right, we've learned a lot of algebra where we don't necessarily need the graphing calculator, although that would help. All right, can we find g of x equals 5 without technology? Do I need a graph to do that? Right, and the answer is no. This is something that, or I guess the answer here is yes, we can do that. Again, it's very much like we did up here, but y is equal to 5. So we're solving x plus 1 over x minus 2 minus 3, right? When's that equal to 5? And so we'll add 3 to both sides. We get x plus 1 over x minus 2 equals, I guess that's 8. Clearing fractions, I'll multiply both sides by x minus 2. And that gives us x plus 1 equals 8x minus 16. So doing some more work, we end up with negative 7x equals negative 17. And that's not a very pretty value, but it's what we get. And so dividing both sides by negative 7, it looks like x is 17 over 7. Or that would probably be 2 3/7, right? So on the graph, right, when we're 2 3/7, I expect the y value to be equal to 5. So we're pretty good there, right? So again, let me circle them. A can be done without a graph. We can use algebra. C can be done without a graph. We can use algebra. D, E, and F don't need a graph, right? We can use algebra. And then we but B, right, range we do. And then C, find the domain values where g of x is less than 0. Well, again, this is y is less than 0. So we're trying to find when are we below the x-axis. And if we're trying to see that, it's kind of like the range, right? Let me asterisk this one. Yeah, we definitely need a graph for this. So the answer is no. When you guys move to calculus, you'll be able to do it without one, but we're not in calculus, right? We're going to build up to that. But right now, for college algebra-wise, we need a graph. What about the domain values where g of x is greater than 0, right? Where is y greater? Well, now we're talking about being above the y-axis. Okay, and of course the answer is no. We can't do this without a graph. We need a graph. Okay, so obviously we now, to answer B, G, and H, we're going to have to come up here and graph this function, see it, all right, and what we're going to be able to do when we see the function is we're going to be able to verify that the domain's everything below 2 and above 2. We're going to be able to verify that 3, 1 is on the graph. We're going to be able to verify that 0, negative 3/2 is an a y-intercept. 5.5 zeros, the x-intercept, and then we're going to be able to see that point 2 3/7, 5 is on the graph. So we're going to be able to see the algebra in the graph and then answer B, G, and H shortly. All right, so let me go ahead and cut this video away, and we'll come back and we'll use technology.